Good day students, welcome to the GATE video online coaching class. Today we are going, myself I'm Ms.A.SHAINI from the Department of C.S.A Engineering College. Today we are going to see about computer organization and architecture. We are going to cover the topics under storage devices, whereas the input interface and interrupt and DMA mode. So these are the topics to be covered today. First we'll see about the introduction and what is input-output interface, what are the different types of interfaces and modes of transfer, and what is DMA, and finally the advantages and disadvantages of DMA, and finally the GATE questions and all. Moving on to the introduction. So for today, in today's topic, we are going to see about what is input-output interface. So input-output is the devices which are connected with the CPU as well as the memory devices, where the informations are being transferred from the input-output devices to the peripheral devices as well as the memory unit. So the basic definition goes like this: the transfer of information between the internal storage and the external input-output devices, we call it as the input-output interface. So these interfaces are nothing but a wired or a wireless connection where we connect the peripheral devices with the CPU in order to communicate with the other devices of the CPU. So CPU is interfaced using a special communication links by the peripherals where it is being connected to the computer systems, and these communication links are used in order to differentiate the difference between CPU as well as the external devices connected with the CPU. So a peripheral device is a device which can be inbuilt device or an external device which is being connected with the computer in order to make its functionality better and to give a better performance. So the peripheral devices can be either an input device or an output device, or it can be of any storage device. So these are some examples of peripheral devices like monitors, mouse, keyboards, and external peripheral devices like USB, SSDs, and hard disks. So efficient and input-output interfacing can be done through direct memory access as well as interrupt enhancing systems performance. So there we have a special hardware which exists between the CPU and the peripherals to supervise and synchronize all the input-output transfers, so that these input-output transfers, we call it as the interface units. So moving on to the simple diagram which defines the input-output interface. So this is a CPU where it is being connected through the bus lines and the address lines, where we have a memory device connected with the input-output subsystems. So these are all called as the peripheral devices, where we have a disk, USB devices, a keyboard, monitor, scanner, or printer, anything. So any devices which are externally or internally connected with the CPU, we call it as the peripheral devices. So these devices communicate with the CPU as well as the memory through these bus lines. So this is called as a system bus, where it is an internal system bus which we have an address line, data line, and a control line. So these input-output peripheral devices are connected with the CPU and the memory through these address lines and data lines as well as the control lines, where these address lines contains the address, the IP address or the physical address of a device which is connected with the CPU, whereas the data lines are helpful in transferring in the data communication, and the control lines control the flow of data between the devices or CPU or the memory. So input, output, and memory bus. So now we can see the functions of the buses. So memory bus we mainly use for the transfer of data between CPU and the main memory. And the input-output is for transferring between data between the CPU as well as the input-output device through a input-output interface, which can be either a wired or a wireless interface. Next comes the physical organization of the system. So many computers, we have a common single bus system, and whereas some systems they use a separate line for the interfaces. So we have two types of input-output interface units in the system here. So first we'll see, first it comes with a common bus, but we have a separate control line for each and every function, where the data transfer is being controlled to each and every devices by a different control line. And next type is one common bus will be there for a system, where we have a common control line for all the input output as well as the memory functions. So some computer systems, they use two different system buses, and one to communicate with the memory and the other line is to communicate with the input-output interface devices, that is the peripheral devices. So input-output bus will be used to communicate between CPU and the all interface units via a common bus line, where an interface can be connected to a peripheral device by a number of data registers or control registers and the status registers. So these registers are involved in CPU communication, where it stores or acknowledges a system link line. So a common bus is passed between a peripheral by sending to the appropriate interface registers. So now we will see the different modes of transfer, how data are being communicated between CPU, the main memory, and the peripheral devices. So first type is programmed input-output, interrupt-initiated input-output, and direct memory access, that is DMA. First, we will see about the programmed input-output mode. So programmed input-output mode is generally defined as a mode of data transfer where operations are results of input-output instructions, where it is communicated with the CPU as well as the main memory by a type of programmed instructions. Like for example, an application software where we use some instructions or some programming languages to communicate with the CPU as well as the peripheral device. So this is a diagram which defines explains the data transfer in CPU using a programmed input-output instructions. So here we have a CPU where it is being interconnected with the interface and the input-output devices. So from the CPU we have an address bus, data bus, and input-output read-write commands where it communicates with the input-output device through an interface. So these interface will consist of a data register and a status registers, where data register will store all the data being communicated from the CPU to the input-output device, whereas status registers, that is we can call it as a flag register, this status register will give you the acknowledgement whether the input-output device is ready or it is not ready for the communication, that is data transfer, to take place. And next type we are going to see about is interrupt initiated input output. In this method, an interrupt is initiated by the interrupt command is used to inform the device about the starting and the end of a transfer. So where in meantime CPU will be involved in executing the other programs. So that this interrupt will be initiated with the CPU, so that CPU will be held up for another program. The current program execution will get over and then it will be freed up for the next process. So when the interface determines that the device is ready for data transfer, then it will generate an interrupt request and it will be sent to the computer. So this is a diagram which differentiates programmed input-output data transfer and interrupt-driven input-output data transfer. So here you can see for a programmed input-output data transfer, we have a issue read command to the input-output device, where the CPU will read the input-output commands from the devices and it will read the status of the input-output device. So in case if the system is ready to accept the commands, then it will send a acknowledgement to the memory, and after receiving the acknowledgement, if the system is ready to receive the data, it will be stored inside the main memory and it will be continuing the process in the same loop. In case if the device is not ready or if it is interrupted by any other process, so it will send an acknowledgement that the device is not ready to accept the data. So again we have an issue command from read-write issue command from the input-output device. So here we have an input-driven input-output, interrupt-driven input-output data transfer, where an interrupt is initiated with the CPU during the data transfer. So here you can see a same issue read-write command is initiated by the CPU with the input-output device, where the CPU takes up some other work until the interruption is over, the CPU will be looking after the current program to get executed. So this also will check the status of the input-output device. If the device is ready, then the data will be written into the memory. In case if the device is not ready for the data to be stored, so then it will initiate an error, where it will be sent to the CPU to initiate a read command from the input-output interface. Moving on to the next slide, we have the third type, direct memory access, that is DMA. So in order to overcome the drawbacks from the interrupt driven and the program input output requires active CPU intervention. That is, without the process of involving the interfaces in between, we can directly communicate with the main memory using this mode, DMA, that is directly accessing the memory. So this method we call it as a direct memory access. So the input output transfer initiating time will be higher and the performance will be very high in the DMA mode. So the processor will be tied up with a number of instructions where it must be executed for each and every input output transfer. So when large volume of data are to be moved from a CPU to the main memory access without involving the other interfaces or devices, peripheral devices, we can directly access the memory in order to store the data. So this is a diagram which explains the direct access of memory from the peripheral devices with the help of a DMA controller. So this DMA controller is the heart of the system where it controls the data transfer between the peripheral devices and the memory unit. So here the peripheral devices will be directly communicating with the main memory. So now we'll see the gate questions. So first, what is the primary advantage of direct memory access? So we have 4 options here. It uses fewer instructions, it reduces the speed of data transfer, it frees the CPU from data transfer operations, it allows multitasking. So the correct option is answer C, because DMA allows peripherals directly to read and write the memory without CPU intervention. So making the input-output operations faster and freeing the CPU for the other task. So the correct answer is C. It frees the CPU from data transfer operations. And the second question is, which of the following is not an input-output interfacing method? We have 4 options listed here: programmed input-output, interrupt-driven input-output, direct memory access DMA, and polling via pipeline. So the correct option for this is polling via pipeline, because in programmed input-output and interrupt-driven input-output and DMA, they are standard interfacing methods, whereas polling is a technique where polling via pipeline is not a direct standard method for input-output interfacing. So as already we saw in the previous slides, so we can come to know that all the 3 modes are the standard method used for input-output interfacing. So we can finalize that pipelining via polling via pipeline is not a standard method for I/O interfacing. So option D is the answer. The next question, in interrupt-driven input-output, what happens when a device is ready for service? And the options are, it waits for the CPU to check its status, it sends an interrupt signal to the CPU, it starts a DMA transfer automatically. Option D, the device writes data to the memory. And the correct answer is answer B. So explanation is, an interrupt driven input, the device alerts the CPU using an interrupt where it requests when it's ready. So this improves the efficiency over polling. So the option is B, it sends an interrupt signal to the CPU. And the next question is, in direct memory access, who has control over the system bus during the data transfer? So obviously from we can come to know that in a direct memory access, we have a direct memory controller which will control the overall process execution or the data transfer. So the option is DMA controller, B. So during a DMA operation, the DMA controller takes the overall control of the system bus to transfer the data between memory and the device directly, bypassing the CPU. Thank you, students. See you all in the next session.